Today we're going to do section 6.5, radical expressions. So we are using the things that we learned from section 6.4, the nth root, and we're going to, work with radicals a little bit more today. So I'm just going to read through some of your notes. I'll probably break this up into two parts. So just reading from the notes, radical expressions can be simplified by using properties. And then it gives you those three properties, which I'm just going to explain to you using real numbers because it just is a little kind of mumbo-jumbo whenever you're reading through the words of it. But this first one is saying that if you have something like the third root of x times y, you can write that as two separate roots. You can break up those factors, x and y. Remember, factors are things that are being multiplied together. So I could change that to the third root of x times the third root of y. And I can work with it in that arrangement instead of leaving it under all one root. And that's just to say if the index is positive, which all of the indexes that we're going to be working with are going to be positive. So you don't have to worry about that part. And the next one is when you have a fraction. So same thing, I'm just going to make this one a square root. If I have the square root of 1 over 2, I can break that up into the square root of 1 over the square root of 2. Now you don't want to leave a radical in the denominator. You want to rationalize, which you should have seen some in 9th grade, seen some rationalizing. And we'll do some examples of that, so kind of keep you or get you back up to speed. But anyway, you can break a fraction up into separate radicals and then work with it like that. And the third property talks about when you're adding radicals together. In order to combine the radicals, the indexes have to be the same, so these two are both square roots, and the radicand has to be the same. These are both 2's. So I can add the numbers in front, treat the radical like it's a variable kind of, and you're just counting how many you have. You have 3 radical 2's with this first number, 5 radical 2's with the second one. So when you combine, you're going to have 8 radical 2's. And that would be simplified when you add them together. Okay, so radical expressions are in simplest form when the index is as small as possible. So your root, the number for your root is as small as possible, and we'll probably work with that more later. Not really much in this section. The radicand does not contain a factor other than 1 that is a root of the index. So that means you can't simplify it anymore. And the radicand has no fractions, so you're not going to leave a radical in the denominator, and the denominator contains no radical. So you're not going to leave a fraction inside a radical or a radical in the denominator. Okay, so let's do a few examples. The bottom part of those notes talk about how to rationalize, and I'm just going to show you how to do it instead of reading through that. Okay, so on the first one, we are going to simplify. So I have the square root of 16 p to the 8th q to the 7th. So square, and now yesterday all of the radicals simplified down and you got rid of the radical totally. You didn't have any roots in any of your answers, and today you're going to have some roots left in your answer. So this one's a good example of that because one of the variables is going to be left inside. So I'm going to take the square root of 16, which is 4. You know what we could do? Let's break it up. I'm going to separate each one of these factors into its own little radical. Okay, so I have the radical of 16 times square root of p to the 8th times square root of q to the 7th. And that might make it a little bit easier to look at for some of you guys because we're just going to take each root. So the square root of 16 is 4. Square root of p to the 8th is p to the 4th, and I don't have anything left inside that radical, so it's all outside the radical now. And then this last one, when I take the index and divide it into the exponent, it goes 3 times, so I have q to the third power, but then I also have one that's left over. I have 1q left over, and that's going to have to stay inside the radical. So writing it all together without any of the little multiplication dots in between, you'd have 4 times p to the fourth, q to the third, square root of q. So let's do another one where you just have a radical left inside. This is not on your, well, let's just do number 2, might as well. Square root of 25, a to the fourth, b to the ninth. So if I broke it up into separate factors, I'd have a square root of 25 times square root of a to the fourth times square root of b to the ninth. Now you don't have to do it like this. If you're fine with how it's originally written, you can just simplify it from that. So I have the square root of 25, which is 5, square root of a to the fourth. If I take my index, divide it into the exponent, it goes evenly. It's just a squared. There's nothing left over, so I don't have any root left. And then b to the ninth, the index divided into 9 is going to be 4, so I can take out b to the fourth, but then I have 1 left over. So that's going to stay inside the root. So your final answer is going to be 5a squared b to the fourth radical b. Okay, so let's move on to number 3, where I have a fraction and a radical. Square root of x to the fourth, y to the fifth. So I'm going to break that up into 2 separate radicals. Square root of x to the fourth over square root of y to the fifth. So now the square root of x to the fourth is going to simplify to x squared. 2 goes into 2 evenly, and there's nothing left over. My index goes into the exponent evenly. But whenever I try to divide my denominator index into the exponent, 2 goes into 5 2 times. So I do have y squared, but then there's 1y that's left inside the radical. There's 1 left over. Okay, so I have to rationalize that. I can't leave that square root of y in the denominator. So if you remember from a couple of years ago in Algebra 1, whenever you rationalized a fraction, it takes 2 factors of y to get it out of the square root, and I have 1 factor inside that radical right now, so what I need to do is multiply the top and the bottom by the square root of y, and when I have radical y times radical y, that gives me 2 factors of y, so I can get rid of the root now. So it's just y squared times y to the third in the denominator, x squared square root of y in the numerator, and that's going to be your answer, your final answer. It's all simplified. So let's try number 5. Number 5 is a little bit different because that's the third root, and I don't know if you can really tell that or not on your sheet, but that index is 3. So I'm going to rewrite that as 2 separate radicals, cube root of 2 over the cube root of 9x. Okay, so I want 9 is a composite number, that number in the denominator. I want to rewrite that as a prime number raised to a power. That way I can see how many factors I have. So the numerator is going to stay cube root of 2, denominator cube root of 3 squared x. So all I did was I changed that 9, a composite number, to a prime number raised to a power, 3 squared. So I can see in the denominator that I have 2 factors of 3 and 1 factor of x. And I have to rationalize that fraction. I cannot leave that radical in the denominator. So I have to think about how many more factors do I need so that I have 3 factors of 3 and 3 factors of x. That way I can get rid of that third root. So since I have 2 factors of 3 already, that means I need to multiply to rationalize it so I can get rid of the root by 1 more factor of 3 and 2 more factors of x. So now I'll have 3 factors of 3 and 3 factors of x in the root, and I can get rid of that root in the denominator. Now since I'm multiplying the denominator by that radical, I need to multiply the numerator by the same thing. That way it keeps everything balanced. Okay, so I'm going to multiply that by cube root of 3x squared. Now since their indexes are the same, they're both 3's, I can multiply the numbers that are inside. 2 and 3, I can multiply them together. So in the numerator, I'm going to have the cube root of 6x squared all over the cube root of 3 to the third is 3, and the cube root of x to the third is x. And that's going to be your final answer. Okay, so let's take a little break, and we'll come back. I'll see if I can find one more example of something like that, and we'll do it together when we get back. See you in a minute.